Lesson 2 in Unit 5 is on solving logarithmic equations and inequalities. And so we're first going to look at a logarithm with the base b. A logarithmic with base b looks like log of x of b equals y if and only if b is equal to y to the x power. And this comes back to the swoosh that I use, and you see x will go out to y and it will be equal to b. So for example, if log base 3 of 27 is equal to y, then 3 to the y power is equal to 27 based on following the swoosh method that I've taught in Algebra 2. Alright, let's look at this one. Example number 1, write each in exponential form. So I'm going to take and draw my swoosh, and that should be 2 to the third power equals 8. So I have converted to exponential form, and I know that this is a true statement because I can use my calculator or from memory that 2 to the third power is equal to 8. And do the same thing here, even with the fraction. We're going to start from this base, go out and back in. So 4 to the negative 4 power is 1 over 256. I know that this is true because with a negative exponent, that puts me in the denominator, and 4 to the 4th power is 256. In this example, we're converting from exponential to logarithmic form, and I'm going to take from 15, go out and back to the exponent. So we're going to say log base 15 of 3,375 is equal to 3. I'm going to do the same thing here. Start from base, out, back to the exponent. Sorry, I was writing what I was reading and not doing what I was supposed to be doing. So we're converting to logarithmic form, so we're going to say log base 4 of 2 is equal to 1/2. And again, you can check these in your calculator by doing this, and I'm going to write the buttons down. If you want to make a logarithm that has a specific base, you're going to hit alpha window, and then you're going to go down to logarithm number 5, and then you can type in a base of 15, and then type in your 3,375, and you get 3. So I'm going to write those steps down right here off to the side. So alpha window and number 5. Okay, let's look at example 5. Example 5 says to evaluate each logarithmic expression, and they have given us just an expression and not an equal sign. So I have nothing to cross over to convert into. So I'm going to go ahead and write equals x out to the side before we start. And then I'm going to draw the swoosh like we've been doing. 16 to x and back to 4. So 16 to the x power equals 4. And then we need to figure out what to the x power is equal to 4. So from there, we're going to change 16 to be a base of 4 so that our bases can be the same. I know that 16 is the same thing as 4 squared. So instead of 16, I'm going to write 4 squared raised to the x power. And remember that this 4 here that doesn't have an exponent has an understood exponent of 1. Now that our bases are the same, we'll set our exponents equal to each other. But remember that power to a power, you multiply. So 2x equals 1. And then I can solve for x by dividing both sides by 2, and x is equal to 1/2. Alright, we're going to do the same thing on number 6. We wrote equals x out to the side, so we're ready to do the swoosh. 1/2 to the x power equals 256. So a couple of things I want to change. I want to get this 2 out of the denominator, so I know that 2 to the negative 1 power is the same thing as 1/2. And then I'm also going to need to change this 256 to have a base of 2. So 2 to what power equals 256? And you can mess around with your calculator to figure that out. Let's see. It's not 2 to the 7th. It's 2 to the 8th power. So that's how I'm going to represent these two now that I know what to plug in. So instead of 1/2, we're going to use 2 to the negative 1 power. And I'm still going to keep that x exponent that was in the original problem so that my values don't change. And then I'm going to change 256 to 2 to the 8th power since they are equivalent. Our bases are the same. Just remember that when you have power to a power, you need to multiply those together. And then we can set our exponents equal to each other. I'm going to have to divide both sides by a negative 1. And so x is equal to a negative 8. Now, be careful when you're solving these logarithm problems. Go back and look at where x is. X can be equal to a negative here because it's on the outside. But if we were looking for an x here or here, it could not be. Okay, so because this is on the outside, or it can be in an exponent, it can be negative, but that's it. Alright, so now let's move on to these next examples. So our equal sign and a number are here, so I don't have to write equals x in order to convert like we did in our previous two examples. So we can go straight away to our swoosh. So that's going to be 36 to the 3 over 2 power is equal to x. And this is easy to figure out. You can use your calculator, or you can convert in your head. Remember that this would be a square root, and then this would be to the 3rd power. You could break it down by hand, whatever you want to do. For time reasons, I'm going to just type it in. 36 to the 3 over 2 power. And that is 216. Same thing here. 16 to the 5/2 is equal to x. So I'm going to show you how to break this one down by hand. So this would be a square root, and this would be 16 to the 5th. So that would be 5/16. But I also know that I can break 16 down to 2's. So 16 is 4 2's. So there's that set. Here's another set. Now I'm doing these 5 times because there are 5 of them. And one more. Okay, so since it's a square root, we would be circling groups of 2 of each. All of them come out. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them. And then if I were to bring that out, I would get 2 to the 10th power, which is 1024. So that was the long way, other than typing it in your calculator if you ever had to solve that by hand. Okay, let's look at this. Property of equality. If b is a positive number other than 1, then log base b of x is equal to log base b of y, if and only if x is equal to y. For example, if log base 5 of x is equal to log base 5 of 8, then x equals 8. So what is happening here is, so long as your log and your base are the same, then you can set your arguments equal to each other and then solve. That's what we're going to be doing here. We have let's talk about one more thing first, though. Sometimes you get negatives, so let's talk about that. You must plug in your results if you get a negative. That x may not work depending on the argument. Alright, so now I didn't want to write that here. I wanted to only show work here. Alright, so example number 9. We've got log base 2 of x squared minus 4 equals log base 2 of 3x. So our arguments are the same, and I am going to our bases are the same. I'm going to set my arguments equal. And so because this is x squared, I know that this is a quadratic, so I'm going to subtract my 3x over and set my quadratic equal to 0. I'm going to draw my man box. I have a multiply number of -4 and an adding number of -3. So I know I need a positive and a negative. That's going to be a -4 and a +1. So we have x plus 1 and x minus 4 in parentheses. So x equals -1 and x equals +4. Now we're going to check these and see if they work. So for example, I want to check by plugging in. And so I'm going to lay my calculator down. I'm going to say alpha window so that I can change my base on my logarithm. And this was log base 2. And I'm going to plug in the -1. So -1 squared minus 4. And hit enter. No real answers. So we're going to check the +4 now. Alpha window, log base 2 of 4 squared minus 4. And that works. So what that means is we can't use this one. We must use x equals 4. And just remember that the domain of log has to be x is greater than or equal to 0. Alright, let's look at the next one. Log base 3 of x squared minus 15 equals log base 3 of 2x. So our logs are the same, our bases are the same. We're going to set our arguments equal. That's quadratic. So I'm going to subtract that 2x over so I can set my problem equal to 0. I'm going to draw my man box. Multiply number of -15 and an adding number of -2 means we're going to use a -5 and a +3. X minus 5 and x plus 3. So that would be x equals 5 and x equals -3. When you check these, you see that we can't use a -3, so +5 is our solution. Alright, solve each equation. Example 11 has log base 4 of x squared equals log base 4 of -6 minus 8. And so here we're going to take and we're going to plug in, we're not plug in, drop our logs and set our arguments equal to each other. I want everything to be on the same side, so I'm going to add 6x and add 8 so I can set my equation equal to 0. Man box, we have a multiply number of 8 and an adding number of 6, so that's going to be a +4 and a +2. So x equals -4 and x equals -2. Alright, so we're going to check these. Alright, alpha window, And let's see, I can't see my problem. Log base 4 of negative 4 squared is 2. And then alpha window, log base 4 of, what was my other one? Negative 2. Oh, I didn't put parentheses. Squared is positive 1. So both of these work. Both of these are solutions. All right. Let's look at the next one. If b is greater than 1 and x is greater than 0, and log base b of x is greater than y, then x is greater than b to the y power. If b is greater than 1 and x is greater than 0 and log base b of x is less than y, then x is in between 0 and b to the y power. Okay, so let's just dive into this. We're going to start by doing the swoosh, just like we would do if there were an equal sign there. And that's going to be 3 to the 4th is greater than x. Okay, hang on, time out. We're still going to do the swoosh to set up, but I always want my variable on the left. I should have thought about that before I wrote that down. So we're going to start with that, and then we're going to have the same inequality in 3 to the 4th. So x is greater than 3 to the 4th, meaning x is greater than 81. Okay, let's look at 13. We've got log base 4 of x is greater than or equal to 3. So again, I'm going to go ahead and write down my x greater than or equal to, and then just remember that it's going to be 4 to the 3rd. Just write your variable first. So then x is greater than or equal to 64. Same thing here. I'm going to write down my x is less than, and then I'm going to say 2 to the 4th. So x is less than 16. But remember, this is less than now. So it's not just less than 16. Come back to that statement that we had. If b is greater than 1 and x is greater than 0, log base b of x is less than y, then x is in between 0 and whatever that solution is. So when you've got less than, you have to say x is in between 0 and 16. Okay, if b is greater than 1, then log base b of x is greater than log base b of y if and only if x is greater than y, and if log base b of x is less than log base b of y if and only if x is less than y. Alright, and then I'm going to give you a note here. If log base b of x is greater than log base b of y, results in x is greater than y, you don't have to do the next step. I can't spell step. For example, log of 2x minus 3 is greater than log of x plus 4. X is greater than 7. Alright, so let's look here. Solve each inequality. Alright, so our logs are the same. So I'm going to drop them and set the arguments to the inequality given. And then we're going to solve for x. And so, sorry, I lost my train of thought. Solve for x. I'm going to subtract the 2x over just because I like my x on the left, and I'm going to subtract my 3 and get a negative 2. And remember, when you divide by a negative, you flip your inequality. So, I'm going to come over here and write a note. Because of the less than, you need to find the two pieces for greater than 0. So you're going to take x plus 3 is greater than 0 from the original, and the 2x plus 1 greater than 0. So x is greater than negative 3 and x is greater than negative 1/2. So x is in between negative 1/2 and 2. And I didn't use negative 3 because I already had a 2 here, so let's write that. Use the closest to 0. Let's look at another one of those so we can piece all of that together. Last one. So log base 5 of 2x plus 1 is less than or equal to log base 5 of x plus 4. Alright, so our bases are the same. I'm going to set my arguments equal. 2x plus 1 is less than or equal to x plus 4. I'm going to solve for x. I'm going to subtract this x over. Subtract that 1 over, and I have x is less than or equal to negative 3. So again, we've got a less than, so I can't just stop here. So now I've got to figure out what x is in between. And so we're going to come over here, and I'm going to take the 2x plus 1 and set it greater to 0, and the x plus 4. And then set it greater to 0, and then solve for x. So x is greater than negative 1/2, and x is greater than negative 4. We're going to choose the one closest to 0, so the negative 1/2, to write our final answer, that x is in between negative 1/2 and 3. Alright, and that's our final answer. If you have any questions, please let me know.